Absolute value functions day 2. Today, instead of taking the equation and graphing it, we're going to go the opposite way. Take the graph and write the equation. Let's start by recalling our, trying to get that straight. Our function that we use for absolute value, y equals a x minus h in the absolute value bars plus k. So basically, we're going to want to write an equation in that form using things that we can get from the graph. Well, one important feature on our graph we can see is our vertex. That's going to be our h and our k. And then we have another point. This other point we're going to substitute in for x and y. So we'll put the -3 in for y. We're going to solve for our a value. Put a 0 in for x, a -2 in for h, so that becomes a +2, and then the 3 in for k. Please subtract the k first. If not, you'll be in danger of accidentally doing things in the wrong order of operations. So we have -6 equals a times the absolute value of 2. Absolute value of 2 is, of course, 2. So we can just divide that 2 on both sides, and we find out that a equals -3. When we put it all back together to write a final equation, we want that a value in there, but we don't want to put a number in for y. So it's just going to be y equals -3, absolute value bar. Don't put a number in for x, but we do want our h and k. So we'll have our +2 for the h and our 3 for the k. So go ahead and try to do that for this next example. So hit pause, try to write the equation just like we did for number 3, and then come back and see if you got it correct. So again, we need to identify the vertex. Our vertex here is 0, 4. That's going to be our h and k. And then we need another point. So we can use 5, 0. That'll be our x and our y. We're going to substitute those into our equation. So we have 0 equals a times the absolute value of 5 minus 0 plus 4. Move the k value first to that other side. So I'm going to subtract that 4. I have -4 equals a times the absolute value of 5, which is, of course, 5. If I divide both sides by 5, I find out that a equals -4/5. And I'm going to look at my picture and see if that makes sense. First of all, should it be a negative? Well, yes, because it's opening down. 4/5 is less than 1, so that means it should be wider, and this one is wider. So all of that makes sense. So now I want to take that and put it back into the equation. I have -4/5 for my a value. It would be x minus 0, which would just be an x. No need to put the -0, plus 4. All right. Let's try one of those, but with a word problem. So go ahead and read example 5 about trying to make a hole-in-one. And then after you read it, start by graphing the points that it gives you in the paragraph. So again, you might need to pause and come back, but I want you to read it and graph those points. That's where we'll start. All right, so when you graph them, you have to figure out what scale to use. On my x, I counted by 2s. On the y's, I counted by 1s. I need to graph the point 2.52. So here is 4. Halfway through would be 3. So I need to go like a quarter of the way through for 2.5. That's my 2.52. That's where the golf ball is. So maybe I'll put a B there for ball. Then we have a point at 9.52. So again, I'm going to come down 8, 9, 9.52. And that point represents our hole, so I'm going to label that H. And we're gonna bank it off the wall at 6, 8. So 6, 8 is the wall. So if you take a look at these points, you can tell if you're taking the ball and hitting it off the wall, it's obviously going to bounce back. We don't yet know at what angle, if it's going to be the right angle for the hole, but you can start to see how it's going to make a V shape for an absolute value. So maybe, and we'll find this out, maybe it's going to come all the way here and hit the hole. Maybe it'll arrow out a little bit wider or shallower. That's what we need to determine. All right, so using what we did on finding an equation, we're going to start with our equation y equals a, x minus h plus k, and substitute in the values that we know. We know that our vertex is 6, 8, so that's going to be our hk. We know the point that we're starting from, 2.52. That's going to be our x and our y. So please go ahead and substitute those in and solve for the equation, and then come back and check. Hopefully you put a 2 in for the the y, a 2.5 for the x, 6 for the h, and 8 for the k. When we solve this, we're going to have to divide both sides by 3.5, which gives us not a very nice number. We don't want to have a decimal in a fraction. So in order to do that, we're going to multiply the top and the bottom by 2 to get rid of that decimal. So we end up with -12 over 7. That's the a value you were going to use. You may not have done that, so fix that on your paper. We don't want to have any decimals and fractions ever. So our equation is y equals -12 over 7, absolute value, x minus 6 plus 8. That was the first part of what it asked us to do. It asked us to write an equation. Okay, we did that. Now it says use that to determine if you make your shot. So we're going to take this equation, we're going to substitute in the coordinates of the hole and find out, do we get it in the hole or no? So our coordinates of the hole were 9.52. So we're going to put 2 in for y and 9.5 in for x. So what I want you to do is simplify this right side and see what you get. So hit pause, simplify, and we'll find out what happens. All right, so we have 2 equals -12/7 times 3.5. -12/7 times 3.5 is -6. -6 plus 8 is 2. So since we find out that our left side equals our right side, we made the shot. Go us. Now, if those would have come up not equal, then we would have said we did not make the shot. All right, next up, we're going to take a look at transformations. We want to figure out how to transform an image to a pre-image. All right, so the labels look like they didn't quite get on here, so let me tell you first that this big V is the image of this little tiny one up here, which is the pre-image. So it started up here, and then it went down to here. So what we want to determine is any transformations that had happened. So it's always good to identify the vertex. This vertex is at 2, 5. And this vertex here is at -4, -2. So we know, or we can count and see that it's moving to the left and then down. So now you need to actually just count and see how many spaces has it moved to the left and down. Hopefully you find that it is left 6 and down 7. So those are two of the transformations that have happened. But something else has happened too. What's the slope of this pre-image here? Well, to go from one point to the next, and be careful of your scale here. This is counting by 1/2. So we would go up 1 over 1, even though it looks like we're going up 2 over 2. And it looks like the slope of this pre-image is 1. Sorry about that. But this one down here, oh,
Attention,
we'll
all
pause and
football
start
players
again.
need to meet in the PAC for the fall sports mandatory meeting at 2:40.